So the idea of a virtual coffee shop is that it's a program that we set up as like a simulation. So it could
Okay.
it could end up being like a kind of game where uh, the idea is if you tell it like a strategy or something for how you want your coffee shop to be managed, then it'll tell you how well it's going. And
Okay.
because we're making it from scratch, it could be very complicated or it could be super simple. But
Okay, so you say simulation as in like you're simulating outcomes of running a coffee shop, kind
right,
of.
yeah,
So, like
yeah,
this would be actually usable in business. You go, changing this parameter of my coffee shop. What's gonna change?
right. Like,
Okay.
does it matter if you have two employees in the morning as opposed to only one employee in the morning? Well, if there's not a whole lot of volume, then maybe it's okay that you only have one. And then like finances, you got to pay everybody and you got to pay rent. And
Right.
if you get like the expensive coffee beans, so it makes tastier coffee, and that makes your customer satisfaction go up, but it's not like enough, so it wasn't actually worth it or whatever. But maybe if you're in a different city, then like the expectations of that group of customers would be different, and so maybe somebody in Seattle where there's really strong coffee culture would be like, yeah, I'll pay $5 for a pour over because I know that that's going to be delicious. But if you tried to go to like Michigan or like Detroit somewhere and have the same thing, then somebody's going to be like, I'm not paying $5 for a fancy cup of coffee. I don't know,
Or a
just
cup of coffee. Yeah.
just trying to play with it. So anyway,
Sounds neat.
I thought I might bring you along in order to see what we're doing. So I'm actually going to start from like actually nothing or very nearly nothing. So the first thing to go through is like, well, how do we even get started? And I think on Windows, the Windows subsystem for Linux is probably the best way to go for programming stuff. So if you don't have the Windows subsystem for Linux, you can search for Windows features, and there's a control panel setting that's turn Windows features on or off. And if you go into that, one of the checkboxes in here is under W for Windows. There we go. Can you see that?
Okay.
Windows subsystem for Linux.
Uh, oh yeah, I see that. That is checked for me.
Okay, good. So then, what I'm in right now, right here, is the Windows terminal, which if you go to the store, Microsoft Store, you can search for terminal.
And so, sorry, this is like outside of the regular kind of terminal that is used by the computer or
Mm-hmm.
something.
Well, so that's a little complicated. The actual thing right here is a standalone, it's its own program. But this program interacts with
Okay.
other parts of the operating system. So if you go to the Microsoft Store and search for terminal, then Windows Terminal is one of the options. And the main advantage of it is that it has tabs and also some other. It's got a lot of customization that I don't use, but the main thing that I get out of it is that it's got tabs.
Hmm.
So if you
But
click,
it would be like a separate operating system like you did with Ubuntu.
well, that's what the Windows subsystem for Linux is.
Oh, okay.
So Windows Terminal is the program on within Windows that you're running stuff inside of.
Okay.
So then when I do this, does it get bigger?
Yes, that's gotten bigger.
Okay, so then this right here, you can see PowerShell.
Yep.
PowerShell is the command or I think it's actually the shell. PowerShell is the shell that I'm using within the terminal emulator. So the terminal emulator is Windows Terminal. The shell is
Okay.
PowerShell.
Okay.
If you don't have PowerShell, I think the regular. Well, I think most Windows computers come with PowerShell on it, so you should be fine. But if you're trying to do this, you can say WSL for Windows Subsystem for Linux, and then you can hit -- list in order to show which WSL options you have installed. And if you hit WSL help, that'll show you all the instructions that you can do.
Whoa.
I'm going to do this install thing right here. And then D for saying which distro I'm going to do. So I say WSL -- install -D Ubuntu. Actually, it looks like I already have an Ubuntu. Yeah, so let's do, instead of Ubuntu, let's do Debian. Hello. Hold up. WSL list online. I thought that was one of the options here. Yes, I should be able to do that. WSL list. Okay. Ubuntu -20.04. Let's try that one. WSL install -D Ubuntu -20.04. There we go.
So that's just like a version of Ubuntu?
Yes. It's I made it confused, but has been installed. Very good. Installing this may take a few minutes.
So are you encouraging me to do that as well?
You don't have to. I just wanted to show how to actually do this. A new username, Caleb. A strong and complicated password.
1, 2, 3, 4, 5.
Updated successfully. Boom. We're in.
I'm in.
That's the Matrix.
We've got a Linux shell ready to go. Awesome. Okay, so first thing you always do anytime you've got a new Linux setup is you do sudo apt install update. And the update, maybe, oh, it would be apt-get, sorry. So apt update goes and checks all the lists of packages to see what the most recent versions are.
Okay.
So that's what all these lines are. Each one of these is a repository that has packages listed in there. So 251 packages can be upgraded. So then we say sudo apt upgrade, and it goes and gets new versions of all them. Because the way Linux works is instead of having one big program like Microsoft Word is one big program, and all the innards inside of Microsoft Word are kind of limited to just that program. Technically, since that one's the Microsoft Office, it's got other ones that kind of share stuff. But what's another program that you would run on Windows? Like Steam. Steam is a program that you install. And Steam has a bunch of like inner workings, but it doesn't really share those inner workings with anything else. Linux is different. All the big programs that you use on Linux are made up of smaller programs, and different programs can share those inner workings because they're all open source. So what this is doing is it's going and getting, it's like if you think instead of being one big Lego brick, Linux uses a bunch of really tiny Lego bricks in order to build up to the same thing.
And then it's a more exact type of customization because you can change those tiny bricks.
Yep. And there's usually, for most things, either there's just one of them because everybody's agreed, yeah, that's going to be the main thing that does that thing. Or there's a bunch of competing options where different people try to do the same thing, but they're competing with each other. So most of these things, I never need to know what they are. Like, it's not super important that Caleb Figures knows what lib ntfs dash blah blah blah. That doesn't matter. Like, all I need to know is these things are used by other programs that I might want to install. So if I hit update, it'll go and check the full list to see if there's any that I have installed that have new versions. And if I hit upgrade, for each one of these, oh, it's going to keep going if I try to scroll. So it's saying, well, these are all install messages, but some of them, as they're going past, it'll say, I'm going to replace this version, and it'll give you a number with this version, and it's a higher number. So just because this is a brand new Linux install, that's why it's taking this long. Usually it's almost instantaneous. Like, you check, and there might be 2 that have updated since the last time you checked, and then you do it and you're done. But done. All right, so I was going to try and make a coffee shop simulation using Clojure. In order to run Clojure, I need the Java runtime environment. So default-jre. Sudo apt install default-jre. That will install Java, which the place that you probably have heard of Java before is Minecraft, because the original version of Minecraft was made in Java. I don't know if it still is.
I don't know, but I also hear, like, you can use Java for pretty much anything, is what people will say.
Yep.
If you need to learn a coding language, just learn Java.
Yep. And then sudo apt install. I don't know if it's line or Leiningen. Let's try Leiningen. Looks like yes. Leiningen is the name of a Clojure installer and project manager.
All right.
So if I've got Leiningen, then I've got Clojure. So this, in order to try and make a virtual coffee shop, first we had to set up Windows Subsystem for Linux. Then once we got Linux, we had to set up Java. And once we set up Java, we had to set up Leiningen. But it should be that if I hit line REPL, yeah. There we go. So now this is Clojure. So if I say plus 1 and 1, that equals 2. Perfect. So the language is working.
So Clojure is itself a programming language?
Yes, Clojure is a programming language.
Okay.
Yeah. So we'll go ahead and, how do I exit this? Quit. There we go. Okay, so cd ls. Okay, let's go line, which is short for Leiningen, new, which will give us a new project, app, which tells it the type of project that I want to make, and then we'll call this coffee shop. There we go, coffee shop. ls is what you do to list files, and the -a just says show me the dot files too. So coffee shop. cd for change directory, coffee shop. Boom. All right, so now I want to open this up in my text editor, code. Okay, It's going to install the server side for VS Code, which is what I want. Boom.
Oh, here we are.
We got Visual Studio Code. I trust all the authors because I made it myself. Very good. All right. Let's see what WSL extensions we've got. I think because, no extensions found in the WSL. This might be too small for you to read.
I can see.
WSL Ubuntu 20.04 installed none. Okay.
Right.
So I want this one, Calva, which is a very, very, very helpful utility for doing Clojure.
Okay.
So I'll go ahead and do that. And then I think there is maybe one other one that I want. Do I even? I think just Calva and I'm good. Okay. So now that I've got Calva, I'll come back here. These files are template files. They're just basic. They're always there. I open up core.clj, and then I say jack into the matrix.
Yo.
Boom. Mine again. Perfect. All right. I think we're in. So now, if I do what I was doing before, which is +1 and 1, then I can hit Alt-Enter, and it will evaluate it right here inside the file. So then I could say like times 2 and 2, and that's 4.
Hey.
Yeah. So now we can start doing Clojure. All right. So in order to make a coffee shop, I actually want to get one more thing set up, installed, and then I'll be ready to start modeling things. And that thing that I still need is called spec. Spec lets you say, this is what the inputs and outputs of a function should be, instead of just writing the function. And I think that's super handy. So to use something that's not built into the language at its most basic, you declare a dependency. And then, or the dependency has to be on Clojure 1.9 or higher, and I think by default, I've got 1.10, so it should be fine. And then I can require Clojure.spec.alpha as S. That means from now on, if I ever do S and then slash, like sdef,
Okay.
then it will know that this S actually means Clojure.spec.alpha, and it'll go get this function from there. So main is going to end up being like how we run this program later. But now we can start defining pieces of our coffee shop using spec. So sdef core/latte.
Hey.
What is a latte made of?
It's got some espresso,
Uh-huh.
and it's got some frothed milk in it.
Espresso.
And in my case, it also has some flavor syrup and some chocolate.
Core milk. Okay. In order to define what milk is, how am I going to represent milk in my program? Milk has, let's see, how did I do this before? Map of.
Did Ben confirm for 4?
Yeah.
So I determined.
Yeah. Milk is going to have what in it? Core volume. Like how much milk are we talking about?
Right.
That's the information that I need to know about the milk. I need to know how much milk there is. I need to know how hot it is. And I need to know if it's tasty or not. Okay, so now I need to, in order for that definition to make any sense, I gotta define each of these, like volume, temperature, and taste. I have to tell Clojure what those are. So core/volume is going to be an integer. So that just means a number. Core/temp is also going to be a number, and core/taste is going to be we'll go ahead and make that a number too. Like it could be from 1 to 10 kind of thing.
All right.
No such names. Oh, okay. I do this. Then I do this. Okay. So that's a volume. That's a temperature. That's a taste. The milk is something that has volume, temperature, and taste.
Mm-hmm.
Espresso is going to be a map of volume because it's an amount of liquid. It's going to have a temperature. It's going to have a taste. Okay. And then a latte is actually
It's a map of milk and espresso.
map of milk and espresso. Well,
So you got 2 maps in a map.
Huh.
Huh. Huh.
Map section. Espresso.
although, yeah, we'll do it that way for now. Core milk and core espresso. Okay, so now there's a function in spec called conform. Conform takes something in, well, you give it the spec that it's supposed to follow. So if I give it the spec for latte, then you can give it something else, def in, or no, just def a latte. What is a latte?
So totes a latte.
A latte is a core milk and a core espresso. So this milk is going to be a volume of how much milk goes into a latte? Like 5 milligrams or something like that.
Sure.
We can adjust that later. Temp is 100. Taste is 10 out of 10. And then this espresso is core volume like 40 milliliters, right?
Sure.
Yeah.
Core temp 100. Core taste 10. Okay, so that is a latte. Now I can take this conform function and say, all right, tell me whether this latte matches the specification for what a latte is. And it says I can't do that. Why? Unable to resolve spec core. Oh. There we go. Now if I do this. Unable to. Okay. If I don't understand why it's not working, I can say unable to resolve spec.
And this is when the coding begins.
Right. Now I got to figure out what did I do? What did I do incorrectly? Let's see. Oh, interesting. I think I used the wrong. No, that seems right. Let's see.
No, I took it back. It's not yours.
Oh, okay. So S keys. That's what I should be using. I misremembered. So if I say this is keys. But then let's go ahead and leave this one map of. Or just collection of. We'll stick with keys for now. Keys. Okay, sorry about that. That was probably confusing.
That's all good.
So let's read that. Unable to. Yay! Success!
Woo!
Ta-da!
Clean off this.
It did it. It did the thing.
So now I have defined volume, temperature, taste, milk, espresso, a latte. I made a latte, and then I gave that latte to the thing that says check and make sure that this is actually a latte. And it says, yep, it is a latte. So then I can
Nice.
say conform. There you go. Anyway, that's all we'll do for now. I just had somebody get here, so.
Well, that's cool.
All right. Cleared off the thing.
So in the future, I might make like a function that says make espresso and a function that says steam milk and a function that says make latte, and it takes in like different things. Anyway,
Yeah. Well, neat. I'd like to see more of that.
Cool.
I might have.
Well, thanks for hanging out
I got
with me,
this
bro.
for Christmas.
We might do this
I-
again.
New Year's, we did our Christmas.
I'd
thing.
like that. Love you.
And-
All right,
Yeah,
love you
have a good
too.
one.